welcome to our lesson on half-angle identities, the final list of identities we're going to look at before we take our module quiz. And the good news with these identities is, again, I can kind of show you where they're coming from. Our half-angle identities are derived from the double-angle identities we looked at in our previous topic. Now, I don't want to go through all of the iterations here, but I want to just show you one example. So this one example is going to be solving this cosine of a double angle, that version of the cosine of a double angle identity for the cosine of x. So right now the formula is solved for the cosine of 2x. We're going to solve for the cosine of x that we have on this side, which means we're going to have to get rid of the minus 1, the times 2, and the square. Luckily, I know the inverse of all those operations. So if I want to solve here, first thing I'm going to do is add the 1 to both sides. And so we're going to be looking at 1 plus the cosine of 2x equal to 2 times the cosine squared of x. And then I'm going to divide both sides by 2. And so that's going to cancel, and I can't really divide anything here by 2, so I'm going to leave this as a fraction. 1 plus cosine of 2x all divided by 2 equal to the cosine squared. And now I'm going to get rid of the square by taking the square root. So we're going to say the cosine of x is equal to, plus or minus, don't forget that little detail when you take the square root to solve, 1 plus the cosine of 2x, all divided by 2. Now, if you're comparing what we have over here for the cosine of our half angle compared to what we have here, those look pretty close, but they're not exactly the same because this isn't half of an angle, and this is twice an angle. So from this step, after we solve, we're going to use a little bit of substitution. So what we're going to do to make this look like our formula, again, the full derivation of this, is we're going to substitute in, or we're going to let, oh my God, I gotta sneeze. This happens every time I'm going to record. So we're going to let a equal to 2x. Now, if a is equal to 2x, if I wanted to solve for x, I would have to divide that 2 over. That means that x would be equal to a divided by 2. So now I can make some substitutions. In place of the 2x that I have here, I'm going to substitute in what I said it's going to be equal to as a. So I'm going to replace that 2x with a. And then over here, in place of the x, I said, well, x, if a is going to be 2x, then a, or then x, would have to be a divided by that 2. So I'm going to substitute in that a divided by 2. So when I rewrite this, I can say that the cosine of, instead of x, I'm putting in a over 2. There's our half angle. It's going to equal plus or minus the square root of 1 plus the cosine of, in place of 2x, I said substitute in a. And then we divide by 2, and we have it. So this is our double angle, this is our half angle identity derived from our double angle identity. So it's a matter of solving for cosine and then using some substitution of the variables, legal substitutions, because that's something that we're allowed to do. We do it with variables all the time. And the same process can be applied for sine and tangent, and then tangent can be manipulated to get these alternative forms. But I don't want to abuse our time here, so hopefully you'll just take my word for it, or you can practice it on your own. It's actually good practice to manipulate these, but you can work through the solving of some of the other double angles and end up with these half angles. Ultimately, though, I just need you to be able to use the angles to do the same types of things we've been doing. Simplify, evaluate, and verify. Eventually, we will get to the solving. All right, so for instance, we're going to try to find the exact value for the cosine of 15 degrees using a half angle identity. So what we have here is where we normally have, this is cosine, where we normally have a over 2. So what we're going to say is that a over 2 is equal to 15 degrees, which means that a has to be equal to 30 degrees. So when I go to write my identity, or use my identity, I'm going to say the cosine of not 15 degrees, it's going to be a divided by 2. So I'm going to take my 30 and divide it by 2, and that should make sense because that's still going to be the 15 that I have here. Okay, so cosine of 30 divided by 2, that's going to be equal to, plus and minus, the square root of 1 plus the cosine of a, again a was 30 degrees, and then we're going to divide that by 2. So plus or minus the square root of 1 plus the cosine of 30. That's our angle in quadrant 1. You've got that right in your left hand. That cosine of 30 is going to be radical 3 over 2, or you can use your unit circle to get that value. Now we're here, and the trig is done. What's left from this point is just arithmetic. So let's try to clean this up. This is plus or minus the square root of, and the top of the fraction, I'm going to try to add 1 to radical 3 over 2. Well, I'm going to look at that 1 as 2 over 2, so I have that common denominator. So 2 over 2 plus radical 3 over 2 becomes 2 plus radical 3 over 2. And that's still over the other denominator, which is 2. And dividing by 2 over 1 is multiplying by 1 over 2. So let me just continue this over here. So if I multiply by a half instead of dividing by 2, then I'm looking at plus or minus the square root of 2 plus radical 3 over 4 instead. Okay? So technically, the cosine of an angle, again, could be positive or negative. That positive or negative is in the formula because we may not know where our angle is, but in this case we do. We know where a 15-degree angle is. 15 degrees being in quadrant 1 means everything should be positive. So although in general the cosine could be positive or negative, in this case we're going to stick with the positive. So positive because 15 degrees cosine in quadrant 1 is positive. So we're going to go with the positive version of the square root of 2 plus radical 3 all divided by 4. And the good news with this is that we can use our calculator to verify that we've done this correctly. So first, let's make sure the calculator is in degree mode. And let's ask it to evaluate the cosine of 15. It gives us the approximation. Now we want to ensure that the exact value we have is going to be equal to the same approximation. So we have 2 plus a radical 3 in the numerator and a denominator of 4, and there it is. So a verification that we did this correct. Alright, so let's try it again. This time we're going to find the exact value of the tangent of 22.5, and because we have a lot of options for that, I specified which half angle identity to use. So again, here is where we normally have a over 2. So if a over 2 is equal to 22.5, that means a is twice that, and twice 22.5 is going to be 45 degrees. So now, plugging right into our identity, we're going to say that the tangent of 45 degrees over 2, which is our same 22.5 degrees, is going to be equal to the sine of a, so the sine of 45 degrees, and that's divided by 1 plus the cosine of a, so the cosine of 45 degrees. So this is going to be equal to, sine and cosine at 45 degrees are both the same. Those are both going to be radical 2 over 2. And then this was 1 plus radical 2 over 2. In my denominator, I'm going to get the denominator of my complex fractions. So down here, that's where I'm looking. I want a common denominator to add those two. So I'm going to leave the top alone for a second. Again, I'm going to look at this 1 as 2 over 2. So 2 over 2 plus radical 2 over 2 becomes, that's my eraser, becomes 2 plus radical 2 over 2. Now in this complex fraction, if I go to rewrite this as a multiply problem, so keep this, change this, flip this one, these are going to end up canceling. Those denominators will go away. So I'm just going to be left with a radical 2 in the top and a 2 plus radical 2 in the bottom. Now technically, that can be rationalized. So I'm going to carry around here. I'm sorry for these snaking notes. I'm trying to simplify radical 2 over 2 plus radical 2, and I have to rationalize this. I do that with a binomial denominator by multiplying by the conjugate of that denominator. So 2 minus radical 2 and 2 minus radical 2. So I end up in the top of the fraction with radical 2 times 2 is 2 radical 2. Radical 2 times radical 2 is just going to be 2, and that's going to be negative. And then in the denominator, I have the conjugates that I'm multiplying, so a difference of squares. We're squaring the first term to get 4, and the last term to get a minus radical 4, which is just 2. So 2 radical 2 minus 2 in the numerator, 4 minus 2 is 2 in the denominator, which means I can divide and get a final simplified form of radical 2 minus 1. No plus or minus to worry about here. And so that's our exact answer. Again, worth verifying with the calculator because it was a lot of arithmetic, a lot of places where I could mess things up. So let's go ahead and look at the tangent of 22.5, still in degree mode, okay. And we said that should be approximately equal to radical 2 minus 1. So let's make sure that a decimal approximation is the same. And it is. Both are equal to approximately 0.41, so we can verify our work, which is just great. All right, so the next two, we're going to work in reverse. Instead of being given the angle, we're given like the expansion, and we're going to work backwards. So we have to match up what we see here with one of our identities. Now, this plus or minus, and then cosine. We have the plus or minus, the square root, and then the plus with the cosine. So that's going to occur in this box here. That's the one it's mirroring. And so we're going to condense this. Actually, let me just write the formula so I don't have to keep looking back and forth. The formula says if we take the cosine of pen. If we take the cosine of a over 2, I swear, it's going to be equal to plus or minus the square root of 1 plus the cosine of a all divided by 2. So if we're looking at what we're given, what we have to notice is that a is being replaced by 12x. So all we have to do to work backwards now is that same thing in our identity, is replace a with 12x. So if I do that, I can say that the cosine of, instead of a over 2, we're looking at 12x over 2, which means this is going to be equal to the cosine of a 6x, and that is all we have to do there. So recognize which identity we have, and then replace a with whatever replaced it. Okay, so same process here. I can see the version I'm looking for. So this is going to be a tangent, doesn't have a square root, and it's 1 minus cosine. This is the version I'm looking for. So again, let me just rewrite the formula here so I don't have to scroll all over the place. It says, pretty sure I asked this thing to go to blue. Yep. The tangent of this half angle, a over 2, is equal to 1 minus the cosine of a over the sine of a. Now again, notice that a was replaced with 5 alpha, so now we just need to replace this a with 5 alpha. So we're going to call this the tangent of, instead of, my goodness, instead of the tangent of a over 2, it's the tangent of 5 alpha over 2, and there isn't anything we can do to simplify that. So that's that. Okay, working in reverse definitely easier. Not that the other work we're doing is difficult, it's just a lot of little details to remember in the arithmetic and the algebra portion. Okay, so be careful with your work there. Now let's look at the fun stuff. And a little sarcasm maybe. No. So number 5, we're going to use a little more space. Again, it's more the arithmetic in these problems that's interesting. So it says first that the cosine of an angle x is equal to 3/4. And it says that x is between 3 pi over 2 and 2 pi. And that means that the angle that we're looking at is in, hold on, let me write this here. So the angle that we're looking at, x, is in, pen, don't start with me, pen. Okay, so the angle x that we're looking at is in quadrant, we know which one, quadrant 4. Okay, quadrant 4, that's almost full circle, so we're between 270 degrees and 360 degrees. So the angle that we're in is looking at is in quadrant 4. But we're going to try to find the cosine, sine, and tangent of the half angle. Which just means we're going to use our half angle identities. We don't have to do any extra work like draw this out, figure out what the sine is, any of that stuff, because our formulas, let's see, go back to our formulas here. If you're looking at sine and cosine, they're both using cosine, and we were already given that value. And also we can find tangent just using cosine, so I don't have to worry about doing any extra solving because all 3 of those identities can be evaluated knowing the value of cosine, and we were given that up front. The only thing we have to be careful with here is the half angle and what quadrant it's in. So our angle is in quadrant 4, but the half angle means this would be divided by 2, and these would be divided by 2 as well. So our half angle is really going to be between 3 pi over 4 and 1 pi. So 3 pi over 4 and 1 pi. 3 pi over 4 is going to be here, and 1 pi is going to be here, which means we're looking at an angle that's in quadrant 2. So it's important to know because the sines and cosines change values when we change quadrants. So that means that this, here, x over 2, the half angles that we're going to be identifying, they are in quadrant 2. Okay, hopefully that makes some sense. Now, let's try to evaluate the cosine, sine, and tangent of our half angles. I'm trying to decide which direction I want to work here. Maybe I'll work downward with these. So let's go cosine of x over 2, cosine of our half angle first. So the formula says that we want to take plus or minus the square root of 1 plus the cosine of our angle, which was given to us as 3/4, and then we're going to divide that by 2. And now, again, arithmetic. The trig part of this is done. So we're looking at a plus or minus the square root of 1 plus 3/4 is really 4/4 plus 3/4. 4/4 and 3/4 makes 7/4, and that's being divided by 2, which means it's being multiplied by a half. So we're going to call this the square root of 7/8. Okay, so you're thinking, oh yeah, we're almost done with this one. But if we really want to simplify this, technically, I can't square root 7, so let's stick that 7, keep that in the radical. I can't square root the radical 8, but I can simplify the radical 8. So this is really going to be plus or minus radical 7 over 8. If you were to break this down, is 2 times 4, which means a 2 can come out of that. So it's going to break down to 2 radical 2. So 2 radical 2 in the bottom, and then technically that can be rationalized. So if I multiply by radical 2 and radical 2, then finally we're looking at plus or minus the square root of 14 in the numerator, and this will be 2, sorry, this should be radical 2 here. I don't know, going too fast. This is going to be radical 2 makes 2, and that 2 multiplied by that 2 makes 4. So our denominator ends up being a nice rational number. That's the point of rationalizing, ends up being a 4. So that's the final simplified version. It's more algebra work than trig work for sure. Now, we got to decide if we're positive or negative. We said the cosine of the half angle, or the half angle that we're looking at, is in quadrant 2. So in quadrant 2, cosine is negative. So we're going to finally say that the cosine of our half angle should be the negative version of the radical 14 over 4. So there's one part of this. And I can tell you're having fun already. I can feel it through my screen here. Alright, let's look at the sine. So, I used red and green. Well, that's okay. I'm going to do red again. The formula for the sine of the half angle. Not too far off from the cosine one. The only difference is instead of 1 plus cosine in the numerator, it's 1 minus cosine in the numerator. So plus or minus square root of 1 minus 3/4. Remember that cosine of our angle is given to us. That gets divided by 2. So plus or minus square root of 4/4 minus 3/4 is going to be 1/4. Pen. 1/4 then still has to be divided by 2, which means it has to be multiplied by a half. And multiplying by a 1/4 by a half means we're going to end up with 1/8. And again, this is going to simplify. So plus or minus, I can take the square root of 1 and get 1 on the top. And I can't take the square root of 8, but I can simplify. We just saw how that simplified. So I'm looking at 1 over 2 radical 2, which again can be rationalized. So radical 2 times radical 2 over radical 2 means it's plus or minus radical 2 on the top, and again 4 in the bottom. So our angle, remember, in quadrant 2 means that although sine could be positive or negative depending where we are, because we're in quadrant 2, the sine should be positive. So we're going to take the positive version of this. We're going to say the sine of our half angle is the positive version of radical 2 over 4. And now we're almost done. So when we go to find the last one, which is our tangent of our half angle, let me go back to blue since green's going to interfere. When we go to find the tangent of our half angle, I have some options. I can use the identity, which I think is going to be a little bit uglier, but remember tangent is a ratio of sine over cosine, so I could call this the sine of my half angle. My pen is being so weird. The sine of my half angle divided by the cosine of my half angle. And that's really only helpful if I've already found those two things, and since I have, it's super helpful here. So if I wanted to use one of my identities the same way I did in those first two with sine and cosine, I could, but because I've already found sine and cosine, I'm going to use those instead. So the sine we said was radical 2 over 4. That's going to be divided by the cosine, which was the negative radical 14 over 4. And those already have common denominators, which is great. So those denominators are going to cancel and leave us radical 2 over negative radical 14. So we're going to rationalize this by multiplying by radical 14 over radical 14. So then our tangent is going to be equal to negative radical 28 on the top and then 14 on the bottom. Now technically radical 28 simplifies. I know, what a bummer. 28, because there's a 2 here and there's a 2 in there, right? It's 2 and 14, which is 2 and 7, so a 2 comes out. So we're going to be looking at, maybe, you know what, let me just back up a step here. Maybe we should have not rationalized here. Maybe we should have just reduced this, then that would save us the work of having to break down the fraction later. So 2 and 14 have in common a factor of 2, so I could make this a 1 and make this a 7. So if I'm looking at radical 1, which is just 1, and then a negative radical 7, then the rationalizing is no different, but the simplifying is going to be. So I'm going to just rationalize by multiplying radical 7, and then my final answer becomes a negative radical 7 over 7, and I don't have to break anything else down. So that's going to be the exact value for the tangent of my half angle. Now, in the big scheme of things, after I've done all that, it doesn't really seem like it was easier than what I did anywhere else, but it's up to you. So you have options if you've already found sine and cosine. When you get to tangent, using one of the identities would be fine. Using the ratio of sine over cosine also going to work. And remember, any of this could be verified if you put it into your calculator. So if you're not sure, by all means, use that to check what you're doing. Alright, so that seems like a lot, but we've only got one left, the last one. We're going to verify that the equation that we're looking at here is an identity. So remember, when we're verifying, we're going to try to look at the side that maybe has more potential, looks a little more complicated, try to simplify that down till it looks like the other side. If we get stuck, maybe look at the other side as well. So I'm going to try to verify this thing from the right. And I have a feeling I'm going to have to go to both sides here. So let me, on the right, first secant. Secant is the reciprocal of cosine, so I can make that 1 over cosine, plus I'm trying to add cosine, which I can call cosine over 1, and I'm trying to subtract 2, which again I could call 2 over 1. On the bottom, I have another secant, so I have another 1 over cosine, and I have a cosine, which again I can call cosine over 1. So the goal here in this complex fraction would be to get common denominators. If I can get all of those denominators to look the same, then they're going to end up canceling out. So common denominator is going to be cosine. So I'm going to multiply here. Wow. Wow, pen. Just wow. I'm going to multiply here by a cosine over cosine. I'm going to multiply here by cosine over cosine. And I'm going to multiply here by cosine over cosine. And now look at all of my denominators. All of them are the same, which means I could add the fractions in the top, I could subtract the fractions in the bottom, rewrite this as a multiply problem, and all of those denominators are going to cancel. So now that all those denominators are the same, I can sort of ignore them and focus on what I have in my numerators, which is a 1. So I'm going to bring that down. And then it's a cosine times cosine, which is a positive cosine squared. And then it's here, minus 2 times cosine of x. And then on the bottom of this fraction, again, my numerator's 1 here, and then minus cosine times cosine, which would be a minus cosine squared. All right, so now the question is, where do I go from here? So let me just think for a second. Maybe don't write this if you're following along with me. I have a trinomial there. I can try to factor. Is that going to help me? I don't know. There's a trinomial on the top, and I know there's a difference of squares on the bottom. So I can factor, but I don't know if I see anything reducing. Alright, so I'm just going to pause on that. Let me go to the other side and see if I can do anything else, because I don't want to make more work for myself than is absolutely necessary. But we definitely have some places where we could factor if I need to go back to that. So even though I'm not necessarily stuck, I just don't want to take this too far, like I said, if I don't have to. So let's look at the other side. I have the tangent squared of a half angle. So I know that the tangent of my half angle formula, or at least one version of it, let me go to red here. So one version says that the tangent of my half angle is a plus or minus square root of 1 minus cosine of x over 1 plus cosine of x. Now that tangent of that half angle is being squared. So if I square that, what's going to happen to the square and the square root and the plus or minus, which is introduced when we square root, is all that's going to go away. So that's going to leave me 1 minus the cosine of x, and then divided by 1 plus the cosine of x here. Oh yeah, I'm glad I stopped on the other side, because now I can see exactly how to arrive at that other side. From this point, I'm going to multiply by the conjugate of my denominator, and what I'm going to end it with is the difference of squares that I have here, and then hopefully the top works out to be the same as well. So on the top, we have 1 times 1, which is going to be 1. Then I have a negative cosine x and another negative cosine x. That's going to be negative 2 cosine of x terms. And then here, negative makes a positive cosine squared x. On the bottom, my difference of squares, which is going to be 1, and then negative cosine squared x. And look at that. Both sides match up. So this side I got to look exactly like this side. I'm glad I did not take that any further. It might have been a mess. And this time simplifying from the left and the right, just a couple of steps actually worked out. So we did it. We verified. And obviously there are other paths, because I could have continued on this side, or maybe I could have started with the right. But as long as we can do something to get both sides to look the same, then we're in good shape. So hopefully you've got enough to get going on your homework. Hopefully you're working through all those problems so I can get you feedback before you take your quiz. But as always, if you have any questions, just reach out. Alright, till next time, take care.